Hello everyone, welcome again in Eng-Man YouTube channel. So this time around, we will continue our water flood series and still about thief zones. Today's topic is about one evidence of thief zones. All right, so again, I take this material from this paper. You can find it on the internet. It's very helpful. I think it's rather simple, but it's very, informative, and the guidance regarding the thief zone is very good. All right, it's very insightful. And the paper is thief zone identification and classification in unconsolidated sandstone reservoir. It's a field case study. All right, so starting from the right picture here, we have our conceptual picture of thief zone. I take the picture from this paper. All right, so we have here the water injection well, very basic, and production well. And I change it to pointer. We have reservoir section here. And for example, in this picture, in the middle, we have thief zones. And of course, the thief zone will have different properties compared to the rest of the formation, compared to the rest of the reservoir. Most likely the thief zone, or it's always, the thief zone will have higher permeability. Not necessarily higher porosity, but of course it's high permeability, high conductivity. And thus, if you inject water through your injector, most of the water will tend to flow across the thief zones rather than the rest of the formation. All right, because the water will find or will prefer the path with least resistance. Least resistance means higher permeability. It's easier for the water to flow through higher permeability channel, and thus it will reduce significantly your vertical sweep efficiency. And if you have reduced vertical sweep efficiency, later on the recovery factor due to water flood will be significantly reduced as well. Okay, so thief zone is a problematic. Thief zone is a problem, especially in water flood. Okay, so let's take a look what we have now in this video. All right, I have 3 points here from the paper and I will read it for all of us. After long-term water flooding, dissolution and erosion of the formation lead to an increase in pore size and permeability. All right, so here it's a very important statement. Now we know that thief zone is actually not natural. It is induced by long-term water flood. Okay, so if you have long-term water flood, maybe years of water flood, especially in sandstone reservoir, now you have a risk of thief zone. Because after long-term water flood, dissolution and erosion will occur, and it will lead to increase in pore size and permeability, which later on it will become the thief zone. Okay, so that's the first point. Be careful with long-term water flood. And then the second point, under the combined effects of formation heterogeneity and gravity differentiation, some zones with large porosity and high permeability will evolve into thief zones that cause channeling between injectors and producers, resulting in ineffective circulation of injected water. All right, so we have initially high heterogeneity, and it will also be supported by the gravity differentiation. So zones with large porosity and high permeability will evolve into thief zones. So initially, thief zone is a large porosity and large or high permeability layer. You have high permeability and low permeability because of heterogeneity. So the starting point is high porosity, high permeability layer, and due to long-term water flood, it will become thief zones, which will be more dangerous than the initially high permeability layer. And the TIF zone will become the channel between injectors and producers. So if you inject water through your injectors, it will just result in water recycling. The water will not give efficient sweep. The water will just recycle up, injected from your injector, produced by your producer, okay? And then you inject later, you inject again the water, and then the water will go into the TIF zone will go into the producer, and so on and so forth. It's just a cycle. That's why we call it recycling. Okay, water recycling. And oil here in this section will be bypassed, thus reducing your recovery factor. Okay, so we understand now. And then the third point, the TIF zones evolves as a result of formation, erosion, and sand production. Okay, we know that. So dissolution, erosion, and sand production, it leads to, the TIF zone. Okay, but the title of this paper or this, this video is One Evidence of TIF Zones. So what is the one evidence? So I will highlight from the paper this. Okay, I take a note from this paper. I will read it for all of us. Okay, so here, as shown in figure 1, so this is the figure 1, significant sand production is observed in some oil production wells, and the injection pressure of the water injection wells is greatly reduced, indicating that the channel is due to the water injection and evolutions of TIF zones. Okay, so what does it mean? Okay, again, I will start it again. I will read it again. Significant sand production is observed in some production wells. So this is actually the producers. Okay, we have on the vertical axis the sand content, horizontal axis the date. So you can see we have increased sand production, or based on the paper, significant sand production. Okay, you connect the sand production with the formation, erosion, and dissolution. This will cause the TIF zone. Whenever you have the sand production, dissolution, and erosion, be careful. Later on, maybe you will have TIF zone. Okay, so this is the evidence. The first evidence, the one evidence, is that we have sand production in sand or in the producer. And the second, which very connected, the second evidence, which is very connected with the sand production, is this one. The injection pressure of the water injection well greatly reduced. Here, so we have on the, the vertical axis, the injection pressure, the horizontal axis, the time. We have initially high injection pressure, but later on, the injection pressure greatly reduced. Why? Because now the water finds the TIF zone. Okay. First, you inject the water, and then the pressure builds up because of injection. But later on, eventually, the water will find the TIF zone. And if the water finds the TIF zone, the water will prefer to flow across that TIF zone. And because now it's much easier for the water to flow through the TIF zone, then the injection pressure will be reduced or significantly, greatly reduced. Okay, so you have two evidences here which are very connected, and thus I just call them one evidence. It's that you have sand production in the sand in producers. At the same time, you have reduced injection pressure in your injector, especially if they are adjacent to each other, if they are close between your producers and your injectors. Okay, so here, if you have increased sand production in your producers, and close to that producers you have injector which experience injection pressure reduction significantly, then that's the evidence that now you have TIF zones connecting the injector with the producer. Okay, so that's the evidence of these diff zones. That's one evidence of diff zone. Right, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next water flood videos. Thank you.